Hello and welcome to the another edition of Turbo Delphi Demos. I'm Nick Hodges, the Delphi Product Manager, and today I'm going to be talking to you about units and how units of code work in Delphi. Delphi allows you to sequester different chunks of code into different units. A unit is a single file of Delphi code that can contain Delphi code. Units can be used by other units and your projects, and the code in those units can be made available across your entire application and shared between units. So the first thing I'm going to do is create a simple console application, as I've been doing. And in this console application, I'm going to go ahead and save the project. And in this console application, I'm going to add a unit. I'm going to go add new unit. Now, the units, when you save them, you can name them anything you want. I'm just going to call this one Unit Demo. And you'll notice that the unit has 4 separate things in it. When it starts, it's completely blank at this point, other than the infrastructure, the structure of the unit itself. First thing you'll notice is the name unit. That defines the file itself as a unit file, a PAS file, if you will. This thing gets saved as unitdemo.pas. And I saved it as unit demo, so it named itself unit demo. Now, the IDE requires that this unit name here and the file name be the same. And in fact, I believe the compiler enforces that as well. So if I were to change the unit name here, that would kind of desynchronize things. So the unit name and the file name should be the same. The unit then is divided up into 2 sections, an interface section and an implementation section. Interface section is the section that defines what the unit will expose to other units. So for instance, if I create a function called add, and I have 2 parameters, x and y here, and have it return an integer, that is a function that I've declared in the interface section, and therefore any other unit that uses unit demo will be able to see the add function. Now the implementation section is where I actually implement the function, and so I can copy the declaration down here, and then I can of course declare the function as result equals x plus y, like so. So the function add now is implemented in the implementation section of your unit of code. The code will also the unit will also expose, as I said, the add function. Now in the interface you can declare types. You can declare a type of tMyRecord here. I could say that it's a record, and then I could have some fields here. Then I can declare variables as well, and any variable declared in the interface section of a unit is a global variable. That is, any unit that uses it will be able to use and access the current value, or set the current value of this given unit, of this given variable, excuse me, like so. So in addition, I haven't mentioned these yet, but in addition you can also declare constant values, which are sort of variables that hold a single value that can't be changed. Constants are declared with a simple equal sign to distinguish them from variables. So now I have a simple unit that has a type declaration in it, a variable declaration, a constant, and a function declared in it. Now, if I want to copy this unit name and go over to project 19, you'll notice now that project 19, since I added unit demo to the project 19 in its uses clauses has unit demo added to it. So now, if I want to, I can, for instance, I can declare another var here of sum, right? And now I can call sum gets add 4 and 5, 4 comma 5 together. And I can use the add function because it is declared in the unit demo. Unit over here. I could also, since I've declared that, I could say my record gets type T my record, like so, and then of course I can use that record over here in this unit in the program here, because the uses clause declares it, and the code from unit demo can be used in my main project. Now, each unit can be used in multiple units, in one unit, in your program, whatever. I could add another unit that had a real simple function in it called subtract. X and Y are integers, and get an integer out of that. I can declare again in the implementation section the implementation of that result gets X minus Y. And now I could take unit 13, which I'll save as, I'll name it another unit, so it's called another unit. So now I can take another unit and put that in the uses clause of the interface unit, like so. And now, if I want to, I could say, I could call, just if I wanted to be really wacky here, I could, could subtract result at 0. It wouldn't do anything. It wouldn't alter the result at all. But you can notice now that I can call the subtract function in the unit demo unit because I have the another unit in my uses clause. Now, one little sidelight to this. The uses clause, there can be a uses clause for both your interface section and for your implementation section. And in fact, since the subtract function is getting called only in the implementation section, I can move this entire section down into the implementation section instead of the interface. My recommendation to you is, if you can put a uses clause entry into the implementation uses clause, do so, and reserve the interface uses clause for only those units that require information about what, or that are required by the information in your interface section. That limits the scope of the exposure of the information and limits the chances that there might be some cross-ups between units. If you ever do get a cross-up between unit, you can specify very specifically what function you want by using the dot notation. You can just declare the unit name dot entry from the unit, like so, and that will work to conflict namespace, to relieve namespace conflictions that might occur with units that have the same types or the same functions or methods declared within them. So most of the code you end up using will be in units. The project code itself actually will be generally, as a general rule, particularly in VCL applications, managed by the IDE for you. So you'll end up doing most of your code in units. For instance, I'll just file new VCL forms application. You'll notice that the project includes a project file, which I can view using view source, and here's the program file, the project file, and it has some code in here that starts the application, creates the main form, and runs the application. That's the main code that actually gets executed, but the actual real work of the application is going to be done over here in this unit, unit 13 here, which is going to have a type declaration in it which represents the form that matches up with your form designer and the form in your form designer. So most of the code you're dealing with is going to end up in units as opposed to projects. So that's it for another edition of Turbo Delphi Demos. Thanks for your attention, and we'll see you next time around.